So there are some, I was saying completing the square method basically is used whereby when you have the denominator, when you have a quadratic equation, you cannot be able to factorize it. So there must be a way of doing what, of integrating, and that's why we are covering now completing the square method that works. And basically these two are the most important. 1 over x squared plus a squared, when you integrate, basically if you go to the table of integration, the SMP table, it is there. When you have 1 over a, the tan inverse of x over a plus c, and then when you have a minus. So the first one when you have a plus, the second one when you have a minus. So you have 1 over 2a ln the magnitude of x minus a all over x plus a plus c. So this is what we shall be using basically to be able at least to do what, to solve quadratic equations that cannot be factorized basically. I hope you went through the notes basically of partial fraction. So let me do an example. I think an example will be able to guide us. Confirm if you can be able to. We do an example to demonstrate all this, how to integrate. So we have the integration of this one, 1 all over x squared plus 2x plus 5 dx. So the first thing that I will check is to check if this, I can be able to factorize this function, because in an exam I will not give you these clues, use partial fractions or anything. I will just be giving you for you to just to integrate. So I'll check first of all if it is possible to factorize this one. So I'll get the product. The product here is 5. The sum is 2. So let's look for two factors that when you multiply you get 5, and when you add you get 2. So basically for 5 we only have 5 and 1. So basically there aren't any factors that you can be able to get to factorize this one. So this one, partial fractions cannot be able to to work. So now I'll have to use completing the square method to solve this one. So my function is this one. Basically what I want is to have basically, you remember what I had given you 1 over x squared. I just want to have either, my main target is to either have 1 over x squared plus a squared, or 1 all over x squared minus a squared. That is my target. Basically, I don't want 3 terms, x squared plus 2x plus 5. I only need 2 terms. That's why we are using completing the square method. So for this function, what you normally do by completing the square, if you remember the one that we had done for what? The one that we had done for completing the square for quadratic equations, the same thing we can be able to use this one. So this one here, I'll take the x squared. I take the term 2x. I divide this coefficient of b with 2 over 2. I square it. And then plus still the 5 that is there. And then I subtract whatever I have added, squared. So you take the coefficient of b, you divide it by 2, and then you square it. Check now my equation. Whatever I've added, I've subtracted. This is what is very important here. The coefficient of b, this one here, whatever I've added, I'm able to see the positive, I've still subtracted. So I've remained with the same equation. Nothing is changing. Please don't use the is equal sign. Here we don't use the is equal sign because there's no is equal sign. The function doesn't have any is equal sign. So whatever you add, you subtract. Whatever you add, you subtract. Whatever you add, you subtract. Very important. So this one now, I'll pair these two up. This one. Let me first of all simplify this one. I'll have x squared plus 2x. 2 over 2 is the same as what? And the same as 1 squared. And then here plus 5. And then plus 1 squared. I've just simplified 2 over 2. Now what I'll do now is to come and take this one now. Take the first 3. This one can be given as basically, they can be factorized as 1, and then I take this one as 1. I simplify the way I've done, the way I've shaded. So first of all, I'll combine this one into one, and then I combine this one into one. So when I have x squared plus 2x plus 1 squared, this one is a difference of nini. I'll just take the coefficient here of x, and here I'll have positive 1, and then I square it. That's normally what we normally do. You take just the x squared, the one that have squared, and you just take without the square x plus 1, and then you square it. Then this other side, I'll what? I'll simplify 5 minus 1 squared, remain it as number 4. As number 4. Don't worry, we shall still do another example. So again, I've said you take the coefficient of b, you divide it by 2. Whatever you're adding, again, you must subtract, so that at least the equations remain the way they are. Now you can be able to see what I have. I have basically one thing and one thing. So I'll go back now to the integration. So I'll have now the integration of x plus 1 squared plus 4 dx. Instead of having instead of having this one x squared plus 2x plus 5, I just have x squared plus 4. But yet again, what we wanted, I was saying we wanted to have something like this one, x squared plus a squared, or 1 all over x squared minus a squared. So the good thing, we have a plus here. So the only thing is that our a is not squared. So I'll need to manipulate the 4. So the 4, I can be able to manipulate it like this. 1 all over x plus 1 plus 2 squared. Because I want squared, I've been able to manipulate it. The 4, I can be able to write it as what? 2 squared. Because I want something that is close to that. Now because I have addition, I'll go to the formula for tan. When you have addition, you go to the formula of tan. The addition is here. I have addition. That is addition. I'll go to the formula of tan. So it says that 1 all over x squared plus a squared dx is given by 1 over a, the tan inverse of x over a plus c. So I'm just reading it from this one. So we shall just be able to compare. We shall just be able to compare. Now, if you check now my equation, what I have, basically, if I compare with this one, let me use a different pen. We are solving this one. We just want a comparison. This one here, now we compare. To write it there. So basically, you can be able to see that my a is 2. If you compare with the integration of x squared plus a squared, then on the x we have an x plus 1. So my x will be x plus 1. So if I compare with that one, I'll have 1 over 2 tan inverse. Now, are you seeing this x here? Here you have an x, here we have an x. But on my equation, I have what? X plus 1. So I'll just have here x plus 1. Again, my a is 2. And then plus c. And I'm done with that. So you compare. So even if you have x minus 1, you'll take the whole of it. You take just the whole of it. After putting like that, we read it with a direct correspondence. Just a direct correspondence on how you'll be able to get it. Just a direct correspondence. Just do a direct. So when you have x plus 1, kindly take it as x plus 1. The coefficient of 2. If you have 4, you can write it as what? 2 squared. When you have 3, I'll do another example when you have a different one and see what we shall be able to get. So that was just example number 1. I can be able to do example number 2. You see another one. The integration of 1 all over x squared minus 4x plus 5 dx. So if you get the product for this one, the product is still 5. The sum is what? The sum is negative 4. The factors, 2 numbers that you multiply to get 5 and then you add to get negative 4. There isn't. I guarantee you. 1 and 5 will not work. Negative 1 and 5 will not work. Negative 5 and 1 will not work because the product is positive. So we need to complete the square. So I'll take what I have, x squared minus 4x plus 5. So what I'll do, I'll take this one, x squared minus 4x. Now the coefficient of b, I take the coefficient of b, I add. the coefficient of b, very important. I add the coefficient of b. So the coefficient of b here is -4. So I'll take as -4. If positive, take it as positive. So negative 4/2. I square that one plus 5. So let me remain with what I had, plus 5, plus 5. That's what I had. And then now whatever I've added, I always subtract. I've added, I want to remain with the same equation. So I subtract -4 all over 2 squared. Very important. So if the coefficient is positive, here the coefficient is negative, you can easily be able to see. If the coefficient is negative, take it as negative 4, you divide it by 2, and then you square it. And you can be able to see the things in black here. Whatever I've added, I've subtracted. So my equation still remains as x squared minus 4x plus 5. It still remains the same. So this one I can be able to simplify. This one can be given as x squared minus 4x. -4 divided by 2. What do you get? -4 divided by 2, you get what? You get this one as -2 squared plus 5 minus -2 squared. So what I'll do, I'll combine the first three. So let's combine the first three and then the last two. That's what we normally do. So I'll take the whole of this one and combine it as 1, and then I'll take this one and combine it as 1. So this one here, I take only the coefficient of x. Here I'll take it as just -2. It is -2. The way it is -2 with all the square. Then now you square it now. This one here, -2. Then here I'll have 5 minus -2 squared, that is what? 4. So I simplify this one. I can be able to simplify the one that is at the end. I know I will have simplified, but it's still okay. -2 squared plus 1. Plus 1. 5 minus 4 is 1. -2 squared, that is 4. 5 minus 4 is 1. Now, we want something like x squared because we have plus. We need x squared plus a squared because we have a plus here. You can be able to see. But this term, we want it to be squared. So I'll manipulate 1. So manipulate 1. 1 can still be written as what? Can be written as 1 squared. I'll not change anything. Can still be written as 1 squared. So I'll come back basically to the what? To the integration. So I'm integrating 1 all over x minus 2 squared plus 1 squared dx. So I go back to the plus. Again, that is for the term. The table says that when you have 1 over x squared plus a squared dx, you'll get it for 1 over a tan inverse of x over a plus c. That is what the table. So we do a direct correspondence now. So let's have our equation now. We do a direct correspondence. So basically, this is what we are solving. This one here. We want to direct basically from what we have in the table. So the final answer will be our a. You can easily be able to see this one here. Match this one and that one, and then the x you match with that one there. So our a is what? 1 over 1, and then tan inverse. And then our x now here is x minus 2. You take the whole of it. Our a is still 1, and then plus c. I can be able to simplify this one. So you do a direct. When you have x plus 1, take it as x plus 1. When you have x minus 2, take it as x inside the bracket. So I'll have this one tan inverse because 1 over 1 is 1, and then x minus 2 plus c. Simple as that. So you do a direct correspondence and then you are done. By the after factorizing, it is a bit easier. Let me do another one. The integration of 1 all over x squared plus 6x plus 7 dx. So again here the product here is 7. The sum is 6, 2 numbers, and then 2 numbers that we multiply, there is it, because 1 and 7 will not work. So we shall use completing the square. So we have x squared plus 6x plus 7. So what I need to do is to get the coefficient of b, which is 6. I divide it by 2, I square it, and then I put it on the other side. So let me have this. The first one, I'll have x squared plus 6x. Then we add the coefficient of b minus 2 squared. So let me introduce a different color just to demonstrate. So I'll have this, the coefficient of b here plus is positive 6 all over 2, and then I square that one. And then plus our 7 still remains as 7. I want you to see whatever I'm adding and subtracting will still remain with the same thing, 7. And then minus the coefficient of b. The coefficient of b is what? Still is positive 6 all over 2 squared. So whatever you add, these are the signs here. Whatever I'm adding, I'm subtracting. So I'm remaining with the same thing. I'm not changing anything in the equation. So from there, what I'll do, I'll combine the first three. I'll combine the first three. So I'll take the first three. So I take that one there, and then I take this one here. So let's see what we're getting. So when you do, I'll take the coefficient of x, which is just x. Positive 6 divided by 2. Positive 6 divided by 2, you get positive 3. So it will be positive 3 here. And then you square that one. And then plus 7. Let me do this one here. Minus. Positive 6 divided by 2, that is 3. 3 squared, that is 9. And let me have it like that. 7 minus 9. Can someone give me 7 minus 9? So I'll get x plus 3 squared. 7 minus 9, that is negative 2. Now this one, I have now a minus here. So I want this one to be the same as x what? X squared minus a squared. So what do I do? How can I be able to write 2 as a square? Let me ask that question. How can you be able to write 2 as a square? Because I want to write 2 as a square. To check this one out. But we know that the square root of 2, we don't have the square root of 2. So if so 2 can be given as the square root of 2, which you don't know the answer, and then you square it. So it's the same as that. You take the square root of a number. Remember 4, you took the square root of 4, and then you squared it. But we know the square root of 4. The square root of 4 is what? 2. So that's why you are getting 2 squared. But because 2, there's no square root, it shall still remain the way it is. So the square root of 2 squared is still the same as 2. This one I'll have x plus 3 minus square root of 2 squared. Because it's the same thing. If you use your calculator, you'll still be able to get it. Why? Because the square root of 2 is not known. We shall not write 1 point something. No, we don't. There's no need of writing 1 point something and then square. No, just leave it in surd form, in square root form. So now we compare. Now we have a minus. When you have a minus, if you go back to the SMP table, I've given you this one for a minus. For a minus, this one was given by 1 over 2a. 1 over 2a ln. You don't have to master all this. They are there in your SMP. And then x plus a. So we want to do a direct correspondence. So basically, let's take our function here. This one here. This is what our concern is. This one here. This one here. So you can be able to see the reason why we are putting in squared, because this one is squared. So this one, our a shall be what? 2 all over 2 square root of 2. Our a is this one here, which is there. Our a is there, and then our x is the whole of that one. So when you do a direct correspondence, you get 1 all over 2 square root of 2, and then ln our x is the whole of that thing. So I'll have x plus 3. Our a, we know the value of a is square root of 2, and then here you shall still have x plus 3 plus square root of 2. And then plus c. So you do a direct correspondence. So for the x, you take whatever that is in bracket, whatever that is under the square. So you take it as x plus 3, then minus a. Our a is square root of 2. Remember, we have manipulated square root of 2, and then denominator plus square root of 2, and then you are done. You don't need to simplify anything. Yeah, that will be the final answer. You don't have to simplify anything. That is the final answer. So you're just doing a direct correspondence. When you have plus, it is tan inverse. When you have minus, it is a lane. You do the correct, the direct correspondence. Let me do another example. This one, square root of. So again, if you get the product and the sum, I guarantee you they will not work for this one. They will not still work. The product here is 24. The sum is negative 10. Two numbers that we multiply together. 2 and 12 cannot be able to work because this one is positive, so there isn't any number you can be able to do with that one. The factors are not there, so we need to complete the square in our equation. So I have a 2x squared minus 10x plus 12. So before we do this one, there's something important that you have to remember. In completing the square, the coefficient of a has to be what? We start from there. The coefficient of a has to be what? We did completing the square method when we were doing we were solving quadratic equations. Yes, Russell, that's correct. The coefficient of x squared has to be 1, our a. The coefficient of x squared has to be number 1. So we need to manipulate this one. So please don't divide throughout by 2. If you divide throughout by 2, you will have changed the equation. We divide throughout by 2 when you have an is equal sign. So we don't have an is equal sign here. Please don't divide out by 2, but factorize. We factorize. We don't divide by 2, we factorize. Why? Because there is no is equal sign. And some people will make that mistake. When you have is equal sign, you can be able to divide by 2, because on the right hand side, when you divide, we have a 0, you will still hold. But for this one, we factorize. So I'll factorize the 2. I remain with x squared minus 5x plus 6. So you can be able to see I've not changed the equation. I've just factorized, but my equation has still remained the same. My equation has still remained the same. I've not changed. So whatever that is in brackets is the one that I will complete the square. So the constant 2 will always remain. So the constant 2 will always remain. Then x squared minus 5x. I take the coefficient of b. My coefficient of b is what? Plus is negative 5. I divide this one by 2. And then I square it. And then plus 6. Whatever I've added, I subtract negative 5 all over 2 squared like that. So you take the coefficient of b, that is negative 5, you divide it by 2 and then you square it. And whatever you add, you must subtract. And you can be able to see my equation is still the same. So I'll combine the first 3 and the last 2. Remember, the coefficient of 2 will remain, but it will not affect any integration. It is just a constant. So I'll do the first 3 and then the first 2. This one I'll get to. So I'll take here, for the x, I'll just take it as x. Then negative 5, I'll just take it as negative 5 over 2. That's how we normally take it, just negative 5 over 2. Then we square this one. So remember, you take the coefficient of x, or 1. Then the one that has a squared, you just take whatever that is inside the bracket, negative 5 over 2. Then this other one, I'll simplify this side. Negative 5 over 2, let me just do it here. At least you can easily be able to see. But when you have a calc, it is easy. 6, negative 5 divided by 2, this is what I'm getting, negative 5 divided by 2. I'm getting negative 2.5, and then I square it. I'm getting 6.25. Let me put it in fraction form. I'll have 6 1/4. So you take negative 5, you divide that one by 2. If you divide that one by 2, I'm getting still negative. You're getting almost negative 2.5. Negative 2.5 when you square it, I'm getting 6.25. But a negative, because there's a minus here. I know it was positive, but there's a minus there. So when I simplify this one, I put the bracket there, I'll remain with 2 x minus 5 over 2 squared. So what is 6 minus 1/4? I just remain with the quarter, like that. So we need to form this one in the form of this one. We have a minus, so I need this one in the form of x squared minus a squared, in that form. So we need to manipulate their quarter. So their quarter can be written as what? In form of squared. Can be written as x minus 5 over 2. A quarter can be written as negative a half. Yes, you are correct. Squared. A quarter can be written as just manipulation because we know the square root of 4 is 2, can be written as a quarter square. So is a minus. So I'll use ln. So this is what I have in the integration. I have the integration of 1 all over 2, and then x minus 5 over 2 squared minus a half squared dx. Now, the 2, I can be able to remove it. Outside is not playing any part in the integration, so let me remove the 2 outside. So I'll have the integration of 1 all over x minus 5 over 2 squared minus a quarter squared dx. Now, we have a minus, so we shall go to ln. Go back to the mathematical table. Let's go to ln. So ln, we had what? We had, if we are given the integration of 1 all over x squared minus a squared dx, this one was given by 1 all over 2a ln x minus a x plus a. This one you just take it from the mathematical table. You don't have to cram it. Don't have to cram it. Now we do a direct correspondence now. So remember their half is not playing any part. So our answer, their half will still remain outside, no problem. Let me use a different pen. So we are doing the direct correspondence. So here, you can be able to see, I hope my arrow, this one here. That is my A, and then the whole of this one is my what? Is my X. The whole of that one is my X. This one is my that. That is my A and that is my X. So what we shall be able to do now, we do a direct correspondence. So in the final answer, a half will remain outside, is not playing any part. Because I have a half outside, then 1 over 2a. Our a, if you check whatever that is in bracket is a half. So I'll have 1 all over 2 and then a half. And then ln, our x is the whole of this thing, that is x minus 5 over 2. And then our a is still a half minus a half. And then I have here x minus 5 over 2 and then plus a half. That is the difference. Numerator is plus, numerator is minus. So I can be able to simplify this one a bit better. This one will be given by 1 over 2. 2 times a half, so you remain with ln. Negative 5 over 2 minus a half. That is negative 2.5 minus 0.5. So you'll end up with ln what? X minus 3. When you add, you remain with plus 2. Sorry, minus 2. Plus C, and you're done. So remember, when you have a factor, you factorize it, and then you just end up remove it outside. It will not affect anything, and then you continue with the normal integration. When you have plus, tan inverse. When you have plus, ln. I'll do another one for like almost like that one. The integration of 1 all over 5x squared plus 25x minus 10 dx. So you'll be able to check if you can be able to factorize, but I guarantee you cannot be able to factorize. We do it by computing the square. So I'll have 5x squared plus 25x minus 10. So again, the coefficient of x squared is not number 1. So what we need to do is remove the 5 outside and remain with x squared plus 5x. Negative 10 divided by 5 remain with 2. So remember always to factorize. Don't divide. If you divide, your 5 will go. So in your final answer, you'll have some error. So what I'll do now, I'll complete the square. So x squared plus 5x. I take the coefficient of b plus, that is positive 5. I divided this one by 2, and then I square it, and then minus 2. I take the coefficient of what? Of what? Of b, which is positive 5. Am I doing the right thing? So negative, I'm supposed to subtract. Whatever you add, you subtract. Because they have added, I must subtract here. pence. Whatever I've added, I must subtract. So I'll have minus what? Positive 5 over 2 still squared. So I combine the first three. When you combine the first three, what are we getting? This one here. So I'll take only the coefficient of x. Then on the b, I have positive 5 over 2. It is positive 5 over 2. Then I square it. This one, when you do this one with the calc, negative 2. Let me see. When we have here, let me see negative 2. We should be able to simplify this one. 5 over 2, that is 2.5. 2.5 squared. That is 6.25. So minus, that is 6 and a quarter. If I'm not wrong, 6 and a quarter. If I do that one, because that one is squared and then there's still a minus. Whatever we added, we had subtracted. So let me do this a calc. Minus 2 minus 6.25. I'm getting negative 8.25, which if I write it, I'm getting 8 and a quarter. I'm getting 8 and a quarter here. I'm getting 5x plus 5 over 2 squared minus 8 and a quarter. Then I can be able to write it in a better way. 8 and a quarter can be given as what? Can be given as that is 33 over 4. 33 over 4. This one is 5x plus 5 over 2 squared. That is minus 33 over 4. Go to write it in that form because 8 times 4 is 32 plus 1 minus 32 over 4. Now I need to manipulate that one to be in we have a minus, so I'll have x minus a squared, x squared minus a squared. So here already we have a squared, no problem, but here I need to make it a squared. So what do? I will introduce square root. Just introduce square root. X plus 5 over 2. This one will be given the square root of 33 over 4, and then you square it. The same thing. You take the square root and then you square it. You still get the same thing. So to help us at least to be able to use the table, this one is just assisting us to use the table. So now I'll have the integration of 1 over 5 is not playing any part in the integration. So I'll remain with what? X plus 5 over 2. Squared minus square root of 33 over 4. It's supposed to go everywhere. Square root of 33 over 4 squared dx. You can be able to see my 5 is still remaining as 1 over 5. If I divided 0, I will not have the 1 over 5. That's why I was saying if factorize, you don't do what? You don't divide. So I'll do a direct correspondence with the one for the term. No, for the ln. Then will be the same as the ln. The ln was given because we have a minus. We have a minus. I'll do the one for the ln. The ln was given by the integration of 1 all over x squared minus a squared dx. One was given by 1 over 2a ln x minus a, x plus a, and then plus c. When you do a direct, 1 over 5 will remain the way it is. Then I'll have here 1 all over 2. Our A is what? Is the square root of 33 all over 4. And then ln. And then our x is what? X plus 5 over 2 minus the square root of 33 all over 4. And then on the denominator, I'll have x plus 5 over 2. And then I'll have plus the square root of 33 all over 4. Plus a constant of integration. So the only thing I can be able to simplify is here. We know the square root of 4 is 2. So this one, we shall remain with what? We shall remain here with 1 over 5. We shall remain with, okay, square root of 33 times 5. Because we know the square root of 4, the square root of 4 is 2. So you can be able to cancel these 2 with the square root of 4. And then this one, this other one, there's nothing you can be able to do. We just leave it the way it is. 5 over 2 minus the square root of 33 all over square root of 4 all over x plus 5 over 2 plus square root of 33 all over 4. So, and then plus the constant of integration. So that one is just a mathematical manipulation that you need to do so that at least you can be able to solve it. But there's nothing new there. You have done a direct correspondence and then you solve. Our x is x plus 5 over 2 and our a is square root of 33 over 4. Then you have done a direct corresponding. Let me do the final example. Final example, I have 1 all over 3 x squared minus 15x plus 21 dx. Again, confirm if you get the product and the sum, you're not able to factorize. So we do completing the square. This is my function that I have. So we said we factorize. So I remain with x squared minus 5x plus 7 plus 7. I'm getting plus 7. So again, I'll complete the square. So you're able to see the same thing I'm doing. So x squared minus 5x. The coefficient of b now is what? Plus is negative 5. If you take negative 5, you divide this one by 2. If you miss on the sign, you are done. And then plus 7. Whatever I've added, I subtract negative 5 all over 2 squared because I want to remain in the same equation. So remember, the sign is very. That's why I'm taking the coefficient. If it is positive of b positive, I take it as positive. If it's negative, I take it as negative. I combine the first 3. So these ones here, the first 3. So I just take the x and then minus. It is a minus 5 over 2, the way it is, and then you square it. This other one, let me just simplify. So I have positive 7, negative 5. That is 7 minus 6.25. I'm getting plus 3/4. I'm getting 3/4. If I do, because negative 5 over 2, that is negative 2.5. Negative 2.5, when you square it, it shall be positive. That is 6.25. 7 minus 6.25, you get 3/4. But now we need to manipulate this one. We need this one to be squared. This one, we need this one to be squared. You remember what we have been doing? We need that one to be squared. That one to be squared. So what do? We shall have 3x minus 5 over 2 squared, and then plus this one. We can take the square root of the whole of the thing, and the square root will be square root of 3 over 4, and then we square it like that. You take the square root and then you square it. It's still the same thing. Why are you doing that? Because we need to manipulate it to be like what we have. So we have plus here. This one is addition. That is plus here. We have that plus. So we need now. If you go back to the table, when you have plus, we said we go to what? The plus is there. So we shall go to tan inverse. When you have 1 all over x squared plus a squared dx, on the table it says the same as what? 1 over a. You don't have to cram this one, it is there in the table. Tan inverse of x over a and then plus c. So we do a direct correspondence. So let's check what we have now. 1 over 3 will be outside, is not playing any part in the integration. So I remain with x minus 5 over 2 squared plus the square root of 3 over 4 squared dx. So I want to do a direct correspondence now. Do a direct correspondence, we see what we are getting. This is what we have. So the 1 over 3 will still remain the way it is. So our a, you can be able to see our a is what? Our a is 1 all over square root of 3 all over 4. Sorry, square root of 4, because all of them are under square root, and then we take our tan inverse, Our x is the whole thing here under the squared, so I'll have x minus 5/2. Our a, we have seen it is what? Square root of 3 all over 4, and then plus c. So we know the square root of 4 is what? The square root of 4 is 2. So the 2 can be able to go up. So here I'll remain with 2. If you can be able to simplify, kindly just simplify. Tan inverse x minus 5/2. Here, nothing much we can be able to do. Let's see. But in the first, we can be able to simplify. We know the square root of 4 is 2. So the reciprocal of 2, it will be able to go up when you're dividing by 1. It will just be able to go up, then you remain with that. So that's how you do it, completing the square method. By completing the square method, that's how you do it. I'll just do one that when you have the same in the notes. Just go through whatever I have now in the notes, because the idea was the most important thing, and then from there we can be able to. So there's an exercise that I've given you, an exercise that you can easily attempt. I think it has 4 questions. 4 questions. Just before the video conference, you'll see an exercise on completing the square. Yeah, attempt those 4 questions. I want to see how you will be able at least to manage. On the note, still there is trigonometric substitution. You can still be able to go through a trigonometric substitution. Is for your own knowledge. If you'll have any problem, you will kindly tell me. But I don't think you'll have any problem, because this one was the most important. If you understand this one, the other one becomes a bit easier. Trigonometric substitution. There's others for square root. The same thing is still being applied, completing the square. So if you have any problems, I think Emily will let me know, or one of you will let me know in the next